Starting off here, going with our finding our solutions of the system of nonlinear equations. Okay, so our goal is to eliminate one of the variables, either eliminate all the x's or eliminate the y's, whichever one would be easier for us. And typically there's usually a better choice. And we can see that here I have negative y squared and positive y squared. And I have a negative 12y and a positive 12y. So I don't even need to make any changes. I can just go ahead and add these equations together, and it'll go ahead and get rid of those y variables. So let's do that. So let's just go ahead and go through the add. 3x squared plus 45x plus 162 equals 0. After that, now we're just trying to solve this equation, right? 3x squared plus 45x. 3x squared plus 45x plus 162. Okay, so I think I can factor all these. Or I can pull out a GCF at least. X squared plus 9x plus, let's see, what's 162 divided by 3? 54. Equals 0. Okay. So now I need to figure out what two numbers could multiply to make 54 and could also add together to make 9. Okay, so I'm thinking, actually I don't know this off the top of my head. Let's see what we got here. Maybe nope, that was a bad choice. Okay. I don't know, you guys have this? No? Yeah? I'm not getting this. Maybe I messed up my numbers, or maybe I'm just missing something very obvious, which is always a possibility. I don't think so. Did I mess something else up in a previous step? Ah, okay. Thank you. So it was the previous step. Okay. Yeah, I was too focused on the 9. Nice. Thank you. I kept looking at my adding, thinking that's where I went wrong. I didn't even look at the factoring. Nice. Thanks. All right, so, well, if that's the case, then I do know this then. So that would factor into x plus 18 and x plus 3. So my x values that I solve for, x equals negative 18, x equals negative 3. Right? Note that the reason we get x equals negative 3 is because of the factor of x plus 3. It's unrelated to this 3 out here. Okay, so remember, that is not part of the problem that we need to get a solution for. So I wouldn't put x equals 3 just because there's a 3 out there. Next, we're going to go back to our equations. We're going to plug in these various values. So I will plug it into the second one, just because. So negative 18 squared plus y squared plus 12 times negative 18. We're going to get some big numbers here. Plus 12 y plus 63 equals 0. Right? Negative 18 squared, 324. 12 times negative 18 minus 216. We'll add together my constant terms. So 324 minus 216 plus 63. Y squared plus 12y. And then, oops, I cleared it. 324 minus 216 plus 63. So I'm getting plus 171. Is that right? I should actually double check all my answers now since I'm clearly really bad at this. Let's see. Okay, so let's see. I blew it again. Let's just cancel this whole class. Why did you guys let me do this? Come on. This whole thing is a wash. Everybody go home. Just let me sit here and talk to myself and get everything wrong in peace. Okay. This is just 9 and 6. I don't know what planet I'm on today. I don't know what I'm doing. Okay. I am delusional. I'm seeing different positives and negatives where they're not there. It's terrible. Okay. So if I actually factor, I get x plus 9 times x plus 6. I actually feel confident this time, but that should do nothing to assure you. Okay, so I'll go ahead and plug in negative 9. 81 plus y squared. Okay, minus, now 12 times 9, these are big numbers. Let me think here, because this will 108. I need to triple check everything that I do before I write it down, is the lesson that I'm learning. Even basic multiplication. 81, now let's try this again. 81 minus 108 plus 63. 36. So that would factor into y plus 6 and y plus 6 equals 0. So y equals negative 6, which means one of my solutions is negative 9, negative 6. So whenever I plugged in x equals negative 9, we ended up with y equals negative 6. So that's the first of my solutions. But let's now go do the same thing, but plug in x equals negative 6 instead. I probably have space. So negative 6 squared plus y squared plus 12 times negative 6 plus 12y plus 63 equals 0. $36. Did that in my head, so it's probably wrong. Minus 72. I did that in my head, so it's probably wrong. Plus 63 equals 0. Okay, so 36 minus 72 would be negative 36. And then negative 36 plus 63 would be 27. That's probably wrong too. Am I inspiring confidence? I think so. Y squared plus 12y plus 27 equals 0. This we can factor into just y plus 9 times y plus 3 equals 0. So we would get y equals negative 9 and y equals negative 3. Okay, so this is another example. Again, like I'm saying, we can't always guarantee that we're going to get the same values when we plug in whatever numbers we get. All right, so now I've figured out that if I plug in negative 6, then these are the two y values that I get. So I have two more solutions of I could plug in negative 6 and get negative 9, and I could plug in negative 6 and get negative 3. So I have 3 solutions. I think this is the first example we've done where this shows up. Usually we've gotten 2, we've gotten 4. Okay, so this is an instance where we get 3 solutions. All right, these curves intersect in 3 places. Okay, is everyone confused enough yet? I sure hope so. Hopefully, like what I was saying at the beginning where my microphone's being weird, hopefully all that crap just wasn't even recorded. My microphone was broken. Hopefully the stream was broken. You couldn't see any of it, couldn't hear any of it, and there's no evidence to suggest that I'm terrible at math. That's my goal. We'll stick with that. Today's going to be a super quick, super review day of Algebra 1. Okay, but just want to make sure that we are have these skills down. I probably wouldn't just have one lesson for this if we were actually in class, but since we're at home doing weird virtual things, then we'll just have a quick little... Oh no, that means we're going to struggle. Exactly. It's Algebra 1 thing, so you know that's going to go well. But I think you guys can pull this off too, right? Because it's literally just graphing lines. I don't know. How do you feel about that? I would like... How about now? Okay. I don't know. I don't know if it sounds the same, different, worse. I had to use a different microphone though, so sorry if it sounds weird. Yeah. Yeah, much lower quality. My actual mic isn't working, so I just have to use the mic that's built into the webcam. Come on. Here we go. Yeah, sorry. I don't know. Okay, so graphing a system is just good old y equals mx plus b, right, where m is the slope, b is the y-intercept, or the y value of the y-intercept. So for example, this first equation, I first graph my y-intercept. Slope tells me to go up 3 over 2, rise over run. 1, 2, 3, 1, 2. 3, 1, 2. And we could just keep going like this, or go the other direction, go down 3 and left 2. Down 3, left 2. And we'll draw a perfectly straight line to represent that and go through it. As for this second equation, it's not in slope-intercept form, but that's okay. Let's just go ahead and put it into slope-intercept form. So I took my 3x and moved it to the right side by subtracting it from both sides. And then I have negative y, so I'll multiply everything by a negative. So y equals positive 3x minus 9. And we'll do the same thing. We'll start with the y-intercept, which is negative 9. 3 I can think about as 3 over 1 for my rise over run. So up 3, 1, 2, 3, right 1, up 3, right 1, up 3, right 1, 3, right 1. Okay? And so when I actually graph these, I can tell that the solution is the point where they intersect. So in this case, the solution is the point, what is that, 4, 3? It's the point where they intersect each other. So that's just good old solving by graphing. So maybe we don't need to, just another method we can use. Right? So, Algebra 1A, you remember it. I know you do. Okay. So next up, talking about graphing systems of inequalities. All right, so we have various rules here that we can remember. But our easiest way to graph anything is, again, just like we did in the last one. If we need to, we'll go ahead and put it in slope-intercept form. Right, y equals mx plus b. So you might remember for inequalities, we'll draw a solid line if we are talking about one of these inequalities. However, we will draw a dashed line if we're talking about one of these inequalities. So strictly less than or strictly greater than, we draw the dashed line. But if it's the or equals to, then we'll draw a solid just line like we're used to drawing. Okay. All right, so these are both already in slope-intercept form. So let's just go ahead and graph them. So plus 3 is my y-intercept. Rise over run, 2 over 3, so up 2, right 3, up 2, right 3. Or go the other way, go down 2, left 3, down 2, left 3. And I'm drawing a solid line because it's or equal to. And usually if we were just drawing this, I would want to shade. So we would say like greater than, so I would shade above that line. But I'm going to wait, since this is a system, I don't want to shade just yet. I'm going to wait to shade at the end. All right, and for my second line, negative 3 is the y-intercept. Negative 4/3, so I can think of that as down 4 and right 3, or up 4 and left 3. Either way. Note that this is strictly greater than, so I'm going to draw a dashed line. And now both of these are greater than, right? The first equation is greater than or equal to. The second equation is just greater than. But so for both of the lines, we would want to shade above. So for the system, though, I want to shade the region that fits both. So for the first inequality, the first equation, I want to be above the green line. So, okay, if I imagine, I'm not going to leave this here, but if I just imagine, all right, this is above the green line. And then I think about the second equation, which tells me also, since it's greater than, so we want to shade above the red line. So above the red line would be all this. Okay, but so when we're thinking about graphing the system, I don't want to shade all of that. I only want to shade the area where the shading intersects with each other. Right? What area would be shaded by both? And so we can see right now that that is this area right here. This area would have the yellow shading and the blue shading, right? Because it's above the green line and it's above the red line. Okay, that's the only area that does it. So let me actually fix this. So actually, the way I want to shade this graph is just by shading this area right here, because it's the only area that's above, greater than both lines. All right, let's go to our next one. Oops. Okay, so first things first, these are not in slope-intercept form. So I'm going to put them into slope-intercept form. So first I will subtract 2 from both sides. Or sorry, subtract 3x from both sides. Then I'll divide by 2. Two over 2 is 1, so minus 1. Okay, so this is one of the equations that I want. And I'll go ahead and change this one before I graph. Let's use blue. Okay, same thing. I'll subtract x on both sides. And then divide by 2. All right, if you have to do a dividing step, just leave it as a fraction. So like I did negative 1/2. Okay, that way we can think about it as rise over run. And so this is the other equation I want. So let's actually graph these. So I'll start with the red one. Y-intercept minus 1. Rise over run, negative 3 over 2. So down 3, right 2. Down 3, right 2. Or the opposite direction of up 3, left 2. Up 3, left 2. This is y is greater than or equal to, so this will be a solid line. And for the blue line, plus 1, so then my slope is negative 1/2, so down 1, right 2, down 1, right 2, down 1, right 2, or up 1, left 2, up 1, left 2, up 1, left 2, etc. Same thing, this is less than or equal to. So let's go ahead and draw a solid line. Okay, so I'll do my double shading at first again, just to illustrate. Okay, y greater than or equal to, so we want the stuff that is above the red line. Okay, so this is all the area that's above the red line. And then less than or equal to negative 1/2 x plus 1. So since it's less than or equal to, so I want the stuff that is below the blue line. So that would be all this. Okay, now again, we actually want for our final graph, our final shading, just to be shaded the area that intersects both of them, right? Which of these regions fits both criteria? It's above the red line and it is below the blue line. Well, hopefully we can see. That's this right here. That is a lovely graph. It's artistic. Okay, so actually, I'll just shade this region right here. Right, this is the only spot that fits both criteria, above the red line and below the blue line. So we're going to make this more complicated by adding in another equation to our system for the graphing, so it'll make it a little weirder. Right now we have 4 choices for our which area to shade. Right, there's kind of there's this area, this area, this area, and this area. But once we add in another system, it'll mix it up a lot. We'll have like 7 or 8 options for where should we be shading, which is what we'll do on Friday. But this, for now, is the end of this crappy garbage class where I don't know how to do math and none of my technology works. Well, it works, but poorly. And so I'm going to head off then to attempt to fix everything before calculus starts. I'll probably just break it more. Right, but any questions? Hopefully this legitimately was just a total review and not difficult at all. Okay. I know you've done it. This would have been like a 25-minute class if I knew how to do math and if things worked correctly. Do you think we can get any review for working with the 3 equations? So like what we did earlier, or are you talking about how I said we're going to do 3 equations with the shading? Or just the solving, just like we do something and get a solution of like 3, -5, 7, or whatever. Just the solving. Yeah, I can do that. I'll add in. Well, I don't know. Do you want me to do stuff in class, like do something like another example together in class, or do you just want me to like send you like a worksheet that you can practice on? Class review example. Okay. Yeah, I'll put that in somewhere in the next class, maybe as the warm-up or maybe just at the end after we do our system stuff. Sounds good. Just if I don't, just remind me. But yeah, I'll put it in there. Okay, cool. Thanks for asking. All right. Hope things are going well. Hope you guys are all doing okay, staying safe. And I will otherwise see you on Friday for a wonderful journey into more math. I'm excited. All right. Take care. See you guys.